Program control statements. We saw previously that in C++, each statement or each individual instruction of a program, like when we declare a variable or when we see any type of expression, it always ends with a semicolon. Each statement is then executed in the order in which it appears in the program. But we also saw that programs are not limited to just one statement. We saw that the statements can be grouped together to form what we can call a compound statement or a group of statements. Each one within the group, of course, will end with its own semicolon, but out of the group or out of the block will be enclosed in curly braces. We see the example here on the screen where we have three statements, statement 1, statement 2, statement 3, each one ending with its own semicolon, but they are grouped together using the curly brackets. However, programs are not limited to a linear sequence of statements. The C++ allows for a program to take decisions and branch off. These are called flow control statements. They serve to specify what has to be done by the program that we write, in which circumstances, and when. We will be looking at statements that do this, which can either have substatements that can be a group of statements enclosed with curly braces, or it can be a substatement on its own, just ending with a semicolon. The first example of the flow control statements that we will look at is the selection statements, the if and else. If basically is written with the syntax that you see on the screen here highlighted. If open bracket condition closing bracket statement. For example, if we have if grade being the variable is the same as 100, then we say your grade is 100. What happens if we were executing a statement in line 1 and a statement in line 2? Then we have a indented statement line 3, then we have a statement line 4. This selection statement if would allow the program to branch out or exit statement 3 and just jump to statement 4 if the condition in statement 2, where the if statement is located, is not met. There is another example where we see a group of statements being falling under this selection statement. If the grade is less than 100, then we have two substatements. These substatements would say your grade is and print the grade or display the grade in the screen. Because these two statements is more than one, we have to have the curly brackets, opening and curly brackets. If we had these main statements 1, 2, and 3, and the condition was not met, the program would branch out of this section of code and execute the statement that will be located in number 3. But if there is a condition that is not met, then there could be another condition which can be compared. This is where we have the if else. The if and else work together. So the syntax would be if the condition statement is true, execute everything, all the substatements within the if, sorry. Else, if the statement, this condition, execute this. Okay? So what is happening is if this main condition is true, we execute all the substatements encompassed within the if statement that they're true. Else, that means the condition would be false. We execute all the substatements in the else. For example, if we have the variable grade being the same as 100, if this would be true, then we would output your grade is 100. Else, meaning the condition was false, would output your grade is less than 100. Other statements that we will look at are loops or iteration statements. Loops repeat a statement a certain number of times or while a condition is being met. They are introduced by the keywords while, do, and for. The while loop simply repeats statements while expression is true. If after executing some statements within the while loop, the condition is no longer true, then the loop ends. And the program continues after the loop. So let's look at an example of a countdown, which is there, the first screenshot here. This is a custom countdown program using a while loop. We see the variable n being assigned the value of 10. So we come into the iteration statement while, and we see the syntax being while the expression. So this expression is saying while n is greater than 0, we saw n being the value of 10. So what will happen? Then the program will go inside this while loop or execute the substatements within the while loop. These substatements are denoted by the starting curly bracket and the ending curly bracket. So we have, well, print out n, which at this time is 10, comma, and then we do a minus minus n, which we know is reducing n. So this will continue and continue until n is not greater than 0, which for example will be when n equals 0. N equals 0, and is it greater than 0? This would be false, so it would stop and it would print left. The do statements, it behaves similar to the while loop, except that the condition is evaluated after the execution of the statement instead of before. This guarantees that at least one execution statement, even if the condition is never fulfilled, is executed. So we see an example again of the here, and we see the variable str type string, and we go into the do loop. And note the syntax. It's do the statement while this condition. So we have do the statement or sub-statements that fall within the loop, and then we have the while the condition is met. So what happens? We have some value that is unknown to us when the string is created, the str variable, and we enter the text. We assign that value that we get the line from the user, and we assign that value to str. Now we print that value, or we display that value in the screen until the user enters goodbye. So this would be allowing this set of code will be executed until the user enters goodbye. Once goodbye is entered by the user, somewhere within this code, this condition would be analyzed. If the string is equal to goodbye, then the loop would finish and it will continue. The for loop, the syntax is for, initialization, condition, increase, and then statement that will be executed. It is similar to the while loop. The only thing that it allows a space for an initialization and a space for an increase expression or decrease expression. It does similar to the while loop that it analyzes a condition expression. So we see here the example. We see here the example of our countdown using the for loop. In here, in the for loop, which begins with a bracket, we initialize the variable n of type int with a value, assigning a value of 10. We check the condition that n is greater than 0. So we say, well, we'll do this for loop while n is greater than 0. And we know the initialization is n equals 10. And we have a decrease of 1 to the value of n. So this for loop will be executing, and n will be reducing by 1 every time. So it starts printing here the value 10. And this for loop will execute, n being 10 would print 10, 9, 8, etc. until n is 0. It would exit and it would print lift off. So it would, the last n that would print would be the value of 1, just like in while loop. Another kind of for loop is where the for loop iterates over all the elements in a range. So it is a specific syntax where you have a range. And the example of the syntax is here: for the declaration, the range, and execute that statement. A range is basically a sequence of elements, including arrays, containers, and any other type that supports the functions being begin and end. We have an example here of this range, which is a string. So we have a variable str type string, and it is hello. That's the value that's being assigned. So we have for char c, it goes through the range str, we would print the character. So what it will be printing at the end will be within brackets, square brackets, the characters in the word hello. Well, that's another example. It includes also this character which is in the string. Now, while these loops are happening, there are ways for the program to jump out of the iteration. In essence, what this jump does, it allows altering of the flow of the program by performing a specific break in a specific location or a specific function. The first example that we will look is the break statement. Break basically leaves a loop even if the condition for it is not fulfilled, and it can be used quite well to break infinite loops or to force it to end before it ends naturally. So if we look at this example here, where we had our count, and we insert a condition, an if statement here, and test where n equals 3, so it will start to count down 10, 9, 8, 7, 6, 5, 4, and when n equals 3, it will print out 3, but then it will come into here and execute the sub-statements within the if and say, okay, the countdown is aborted, and break. Therefore, it will break out of this for loop. The result would be what is displayed here. The continue statement, it causes the program to skip the rest of the loop in the iteration being executed, as if the block of statements have been reached, the end of the block of statements. So what happens if it was in this for loop, for example, and we had a continue, it would just jump to the beginning and not continue executing what is at the end. Here we have the example, a continue loop. So we have for int n equals 10, and then we test if n equals 5, then we say continue. What happens? We won't execute the rest of the code that is here, but we will jump to the for loop. So at the end, n would have printed 10, 9, 8, 7, 6. When it is 5, it will test, but the statement that's within the if is the condition is true, is continue. So continue just jumps to the beginning, as already explained, of the for loop, because the for loop statement is still not, the end is still not met, but it does not execute all the other substatements that follow. So 5 would not have printed, and then you have 4, 3, 2, 1, and etc. So this is what would have printed. The goto statement, it allows us to make an absolute jump to another point in the program. The syntax for the goto is that it uses a label. So in this example, we have a label mylabel, and my label, what it does, it executes this statement, cout value of n, and so what happens when the program starts to execute, it will go execute one line by one line, or meaning each statement at a time. Once it reaches to the if, where it says if n is greater than 0, it will execute the substatement, which is go to my label. And what this will do, execute an absolute jump to my label, and what does my label do? Prints out n. So we'll still print 10, we'll print 9, because it will be sending it up here while n is greater than 0, all the way to 1, which n will be still greater than 0. It jumps to my label, prints 1, then 1 minus 1 equals 0, comes here, is n equals 0? Nope. So then it continues, and then it will print lift up. Go-to statements are not really used, as far as I know, in nowadays, but it's there for you to use. Another type of statements is the switch statement. It's very interesting. It's similar to the if, then, else if conditions, and it uses labels here as well. The syntax for the switch statement is as shown here. Switch the expression, case, constant, group, statement 1, break, and so on. What happens if the condition is met? Then, if for example, if the expression being tested has a condition that is the result is constant 1, then the group of statements 1 are executed, and then it breaks the switch. If it is not met, then it goes and tests if it was the constant 2, the result. If it was constant 2 and constant 2 is true, then it executes the group of statements 2, then it breaks. And so on, it goes all the way. If it does not find a correct result, again, if the conditions or of the value of the expression at the end is not found in any of the above cases, then the result is that it executes what is in the default group of statements. Although this label, the default label, is optional, but it's nice to put something there.